Welcome back to example 2. Here's your riddle. I am a man. If Jason's son is my son's father, what relationship am I to Jason? Alright, get right back to you on that. Okay, example 2, no diagram for us this time. These become a little bit more tricky, but I think you guys can handle it. I'm going to show you a method that I use. I want to walk you through the problem from start to finish. Okay, where's my ruler? Alright, here we go. So when I draw the cross sections onto the base, I always like to start with my x-axis going in this direction, and my y-axis. It gives me a little bit more, a little bit better perspective of what's going on. So let's see here. We've got this being the x-axis coming at you this way, and this being the y-axis going out away from us. And then we're going to go ahead and draw these curves. We've got, now anytime you're drawing your little tick marks on the axes, try to make every line either vertical or parallel to one of these axes. Okay, so it gives it that perspective. You get a little drawing class here as well. That was a bad one. Okay. I won't take the time like I am now on the future videos, but I just did want to show you how to kind of make it up here 3D. Okay. And I'm going to draw the line y equals x plus 1, so we can see this. These are the positive, where I have the y and the x, those in the positive direction. So y equals x plus 1, let's see. Let's get over here, and x plus 1 has a y-intercept of 1 and a slope of 1, so we get a line. It's linear, right? Goes out that way. Okay, and again we have an y-intercept of 1 and a slope of up 1 over 1, so that's the line y equals x plus 1. And then a little bit more care needs to be taken when you're drawing the x squared minus 1. And again, your success in this section depends on how well you can graph. X squared minus 1 is a parabola that has a y-intercept of -1. And it's a parabola, right? So it's going to go up here, and it's going to cross this line here, probably when x is equal to 2. Let's see if we get the same value. 2 plus 1 is 3. 2 squared minus 1 is 3. So yeah, it's going to be 2 and 3. So right out there, I didn't do that very well, sorry, a little off, but anyway, it's going to have an x-intercept of 1, so it's going to come out like this. Okay, so something along those lines. That's part of the parabola, and then the parabola kind of winds itself up over here and goes out that way. So you can see the base of the parabola. Let's see, where's my pencil? Oh, pencil? Here somewhere. Alright. Just want to shade in the base of the figure. So this is going to be now our base. And you can make, the bases can be in any shape at all. Now, let's go ahead and draw the cross section. I like my cross sections in orange. And again, when you're drawing drawing lines, let's make sure that they're parallel to one of the axes. Okay, and so I'm going to just draw a cross section. What are our cross sections? Oh, semicircles. Okay, so there's the base of our cross section. The semicircle is going to come up like this. Can I get a visual on that? It'll come down like that. Okay, and then this guy comes out here. And go like that. Go like that. Okay, and then the base that you can't see looks like that. Not super great, but I think you're getting the idea. Not too bad. Okay, so there's our semicircular cross section perpendicular to the x-axis. And so you can see the base perpendicular to the x-axis. Let's make sure we we indicate that guy right there. That's what we're looking for. That's our bread and butter. We need to know what that is. Okay, so we can easily find that length because we know how to find that's vertical. Okay, it's a vertical line from this curve here, y equals x plus 1, all the way down to the curve y equals x squared minus 1. Okay, and so let's just go ahead and draw over here to the right a two-dimensional. So let's just draw the face of our cross section. Face, just like we did in the last. I almost got you. Face of cross section, just like we did in the last problem. Okay. And the face of the cross section, we know that this distance right there is going to be the top curve, which is x plus 1, minus the bottom curve, x squared minus 1. So that's the diameter. And let's clean that up a little bit. X plus 1 minus x squared plus 1. Let's write it in order. Negative x squared plus x plus 2. Okay. So that's our diameter. And obviously if we divide that by 2, we're going to get the radius. And what do we need? We need the area of the face. So the area of the face of the cross section. And the area of the face is pi r squared divided by 2. Okay? So we have pi. Now the radius, be careful, the radius is negative x squared plus x plus 2 divided by 2. But then we divide that thing by 2. Let's just multiply it by 1/2. Okay? So that's going to be the area of the face. Let's clean that up a little bit. And let's get pi r, that's r squared. Let's not forget about that squared. It's got to check everything. Pi r squared. R is that. Okay, so I'm watching, I'm checking. Okay, there's a r squared over 2. All right. So that means if we factor out, we square the 2, and that's 4. Multiply it out here. We get pi over 8 times negative x squared plus x plus 2 squared. Okay, so that's as simple as we can write that area of the face. Okay, there's our bread and butter right there. And now we go back and we use that in our problem. Okay, so we're just going to integrate from left to right, and then we'll find our volume. Okay, so back to the picture. We've got, let's see, where's the blue? So we want to write our total volume equals the integral from a to b. Well, what's our a and what's our b? Well, you can see here, sometimes you'll have to work for these a little bit more, but you can clearly see that negative 1 would be the left hand of the x-coordinate of the point of intersection. And just to confirm that, if you plug in a negative 1 into both, you should get 0. We have y equals negative 1 squared. 1, that's 1 minus 1 is 0. And then y equals negative 1 plus 1 is 0. So negative 1 works in both. Therefore, negative 1 is our left hand, or our lower limit of integration, the leftmost point in which these semicircles would start before you start integrating. And then the rightmost point, we already said that the coordinates of the point of intersection over here are 2, 3, 2, 3, and again 4 minus 1 is 3, 2 plus 1 is 3, and so our rightmost limit of integration, or upper limit of integration, is 2. And the total volume is the volume of one cross section. The volume would be area of the face, pi over 8, multiplied by negative x squared plus x plus 2 squared. That's the area of the face, and we multiply by the dx. And this guy right here, again, it's bread and butter to get that area of the face, and you should get 3.181. And there you go. So if you look back at the work there, most of the work was getting that area of the face. Okay, actually a lot of the work was just drawing the picture. And I'm not going to do that in front of you guys the whole time, but figured it'd be good for you to see it. Back to the riddle. I'm a man. Jason's son is my son's father. What relationship am I to Jason? You would be Jason's son. Okay? So you can pause that and read that if you'd like to, but I'm going to be out of here.